Yes. So, welcome everybody. Are we enough?
No.
Shall we wait?
Yes. Let's take 2 minutes, it's 14, 15, 16.
Yeah, I think we are waiting for a little bit longer. Maybe? Okay.
I think that we can start.
Yes. Okay. So good afternoon, good morning, good evening from around the world. And thank you for joining. This is a coastal resilience webinar series organized by the DCC for Coastal Resilience and its allied partners, CMCC, the Climate Center Foundation in Italy, and Deltares in the Netherlands. And this webinar series is part of the Sustainable Coastal Growth and Resilience course, and is curated by, again, the DCC in Coastal Resilience, the Ocean Teacher Global Academy, the University of Bologna, and HR Wallingford. Today's agenda is to have my short introduction of the topics and the general structure of our center and the partners. Then a presentation by Dr. Marie Pendle from HR Wallingford, and then a discussion with questions and answers. We will not give you the floor. We just would like to ask you to fill in question and answers part. So the Coastal Resilience School, the first course that is running now, is called the Sustainable Coastal Growth and Resilience. And it is a course targeted to early career professionals, scientists and consultants, environmental agencies. Is what I call a continuing education course that informs the people, especially, hopefully, young entrepreneurs and professionals, on the advanced tools and information and methodologies. So it is a 10-week online course, and we're running it from January 27. We had, and we will conclude with 1 week in person in Italy from 7th to 11th of April where some of your teachers and the director of the school will be present. Some of your teachers, some of the students' teachers will be present. It is fully funded, and so there is no fees for participation. So, as I said, we are a center of the UN Decade for coastal resilience, enhancing science and stakeholder engagement, science information interfaces with stakeholders. And so the center and its partners, Deltares and CMCC. Here you see some QR codes you can connect to their sites. So we are honored and very happy that Dr. Marie Pendle from HR Wallingford has joined us today for this seminar. And she will illustrate a very important case study of dredging projects and their methodologies for environmental impact assessment. Mary is a marine environmental scientist with over 30 years of experience in marine ecology, water quality, and sediment quality. And she works at HR Wallingford, one of the supporters of our course, contributing to and leading marine environmental impact assessment. Marie has also an extensive experience with the European environmental legislation, having contributed to UK consultations for directives like the Habitat Directive and the Marine Strategy Framework Directive, very important for protection of European coastal seas. So let me conclude this brief introduction by saying that we have the Q&A session. The audio and video are deactivated by default. So if you need to intervene, you write please in the Q&A section. Please note also the recording. This webinar will be recorded, and we ask your authorization for the recording and for future use of education and promotion, for educational and promotional purposes. So again, thank you, Marie, for joining us, and the floor is yours.
Thank you, Nadia. Let me get my share up. There we go. Hopefully everybody can see it now. Thank you for the kind introduction, Nadia. Very happy to have been invited to take part in this. And as Nadia said, I'm going to look at two dredging projects discussing differences for EIA. Nadia gave me a very kind introduction. It is worth saying that dredging has been somewhat of a continuous thread throughout my career. That's why I chose dredging. It's one of the topics I know very, very well. But what I really want to say is that in environmental aspects, the context is everything. I'm going to give you a comparison between two dredging projects in different parts of the world. So they're very similar activities, but in very different environments. Why does this matter in terms of environmental impact assessment? So, London Gateway Port. The project description, London Gateway was a new cargo terminal, and in order to get the container ships in, out, and turned safely, it needed a capital dredge, that is dredging a new area or to new depths, of 31 million cubic meters. The dredges being used, apologize for the acronyms, cutter suction dredgers and trailer suction hopper dredgers. that does matter a certain amount because different dredgers act in slightly different ways. The project London Gateway on the River Thames in a temperate climate. Now, again, climate can make a change to how the environment functions. As I said, the area was for a berth, a turning circle, and quite a long channel. The duration was over 4 years, and it was predicted that there would be continuous maintenance dredging following the initial capital dredge. Now, the River Thames has a high industrialisation level. It has been used 2,000 years as a port, and concurrently there are various different types of works alongside of the River Thames. Obviously, it also flows through the middle of one of the biggest cities in the world. So there is plenty of interference from anthropogenic effects. Man has quite a big influence on this part of the marine environment. It has a tidal range given as about 7 meters, but of course this varies from neaps to springs. There's minor input from freshwater environments. There are various tributaries that run into the Thames. There are habitats near to the London Gateway port of mudflats and salt marsh. And the normal suspended solids, total suspended solids in the waters range from 50 to just less than 2,000, sometimes greater than 2,000 milligrams per litre. It's a very muddy estuary. But the water quality, according to the Water Framework Directive, many EU countries are monitored for water quality, is set as moderate to good. Because it is a muddy estuary, the species are adapted for low light conditions. Often you can see only a few meters, sometimes even less than. There are high suspended sediment concentrations, and it's a dynamic seabed environment. Because mud suspends easily, the mudflats move around. And there are variations in salinity due to the freshwater input. You know, at certain times of the year, if we've got very high rainfall and all of the tributary rivers are running high, then salinity drops. So the dredging operations of the capital dredge might add 100 to 250 milligrams per litre sediments at peak. And that's around about a 10% increase at peak. So when the environmental impact assessment was done, there were various computer models run to have a look at what would these new suspended sediment concentrations look like. This is just the output from that model. You can see that there are occasional high concentrations. The black here shows that there was concentrations of 2,000. This will be on top of what is naturally being pulled up, and that there might be deposition in certain areas in the channel. And then we have what was predicted, the red line, and the observations, the blue and the black. The grey at the top just shows you the tidal range on that particular day. So you can see the neaps and spring cycle happening. But the suspended levels actually remained quite low. 1,000 was the highest that was actually found. So moving to Darwin Harbour, This was a new liquefied natural gas site, so they needed to dredge to bring in the tankers for the liquefied natural gas. That required a capital dredge of 16.7 cubic meters. The dredgers were going to be a backhoe dredgers, cutter suction dredgers, and trailer suction hopper dredgers. Darwin is in the north of Australia and has a tropical climate. The area of the dredge was to produce a berth and a shipping channels, and the project duration was 5 years. You will note that there is no maintenance dredge mentioned for Darwin. So Darwin Harbour is much more pristine than the River Thames. There is low industrialisation. In fact, it is a fairly beautiful, natural-looking harbour. It has a similar tidal range, however, around about 8 meters. As I said, again, this will vary according to springs and neaps. It has very minor freshwater input, and it has lovely habitats of mangroves, corals, and seagrass. But look at the total suspended solids in this area, 3 to 73 milligrams per litre. That's very different to our muddy Thames. And the water quality in the area, very little industrialisation, very, very natural. The water quality there is excellent. So the biological elements, you've got these high profile species. It's sadly true that charismatic megafauna, such as your marine mammals and your turtles, are very much more appealing to people than, you know, the little worms that live in the mud in the Thames. But, you know, mangroves, seagrasses, corals, they're all very high profile. These species are typically adapted for low turbidity, high light levels, and consistent salinity. The Darwin Harbour area is rocks and coarse sands. They do not experience, even in, you know, fairly serious weather events, they don't experience high levels of suspended sediments. Unfortunately, dredging does produce these high suspended sediment concentrations. So even if you are adding only 2 to around 50 milligrams per litre, and I will come back to that figure in a moment, the dredging operations are adding 100 to 200 milligrams per litre. It's equivalent to from 2 to 100 times more. So effectively 200% to 10,000% more. Obviously, that's not something that you take lightly when you are looking at the environmental impact assessment. There were, again, in the environmental impact assessment, there were models run to look at what the predictions would be. There was then monitoring that took place to look at, did the turbidity actually match up to the predictions from the environmental impact assessment. And there were places where it worked fine and places where, you know, there were those high sediment concentrations. You can see they sort of get trapped within the area of the estuary, this area here. The higher suspended sediments were the most of an issue. So comparing between the projects, the suspended sediment concentrations at London Gateway mostly stayed within the natural variation that could be caused by weather events. Obviously, in a temperate climate in the UK, we have quite a lot of storms on a regular basis. it would be difficult to actually predict when we are going to have storms in the UK, but it generally tends to be when the jet stream dips across the country. We get high winds, we get quite considerable wave action, and that moves the sediments around. The clay, as I said, the seabed is muds and fine sand. They're much more prone to suspension during heightened weather events. But the suspended sediment concentrations at Darwin repeatedly exceeded the natural variation by a great deal, by up to 100 times. That meant that when the environmental impact assessments were being done, there was considerable concern about how to control suspended sediment concentrations at Darwin in comparison to Gateway. That's not to say that Gateway didn't have concern about where sediments were being deposited, because that can have effects, but generally didn't matter too much. It's something that's within natural variation. The dredgers at Darwin, the various different types of dredgers, were deployed very carefully in accordance with the EIA suggestions. So methods of dredging were changed around to minimize the suspended sediment concentrations, and there was monitoring to give effectively an upper level. It was real-time monitoring of the suspended sediment concentrations, of the turbidity, and there were stop checks put in place whereby if suspended sediment concentrations and turbidity reached a level where they considered that either the corals or the seagrasses might be in danger of either being shaded from the sunlight because there was too much suspended sediment in the water, or they were in the situation where anything else was being affected. They set threshold levels, and if those threshold levels were exceeded, they went into adaptive management. Could they change the method of dredging in order to bring the suspended sediment concentrations below the threshold to safeguard the environment, or did they have to cease dredging? Obviously, ceasing dredging is very expensive. It's a last resort, but adaptive management, this having the real-time idea of we're exceeding a threshold, we'll move to a different methodology, was something that was done. And, you know, this was a way of protecting those seagrasses, protecting those corals, protecting the other natural elements. So it's a very different approach in the two EIAs. You know, it's a major impact at Darwin. It is a minor impact at London Gateway, and those mitigation methods had to be thought about very carefully. I'm going to expand a little bit on this. You know, the flora of the Thames, seaweeds and salt marsh plants that live in the entire tidal zone. In Darwin, we have seagrasses in the subtidal and mangroves in the intertidal. Seaweeds aren't really impeded by sediment movements, and salt marsh plants rely on sediment deposition. You know, they actually need to trap those sediments to give themselves the nutrients to continue to grow. Seagrasses and mangroves, in contrast, the seagrasses can be shaded by turbidity in the water, which impairs their photosynthesis. Mangroves have very specialized roots, and both seagrasses and mangroves can be affected badly by sediment deposition. That is, they get smothered by sediments landing on them, and it has a deleterious effect. So you can see why we would want to, within the environmental impact assessment, take into account what needs to happen to safeguard the seagrasses and mangroves, whilst the seaweeds and salt marsh plants might be very much better off. In both cases, you probably want to monitor. You know, you predict in an environmental impact assessment, you make the evidence as robust as you possibly can, but there are always elements of chance and change, and you want to also validate your predictions. So monitoring is a tool not only to safeguard the environment, but also as a sort of a rolling knowledge base. The more you can get out of monitoring, looking at your predictions, how did it actually go in reality? What were the things that affected it in reality? You know, I have touched on extreme weather events because they're one of the least predictable things we have. You know, meteorology has come a long way, and you might have a nicely accurate forecast for a week. You're not going to have a nicely accurate forecast for what happens over 5 years. And I think everybody has experienced, you know, storms, hurricanes, typhoons, floods, droughts. All of these things have an effect. And the more monitoring that can be done to validate the predictions, the better idea we have of the resilience of our natural environment and the effects that actually manifest by doing projects like dredging. So we have these monitoring regimes need to take into account the different baseline environments and the biological elements in order to forecast the impacts. As I said, there were extensive monitoring regimes as mitigations from the EIA process to compare predictions against real outcomes. And I have touched on the adaptive management, which was built into the monitoring. If things do go wrong, if you are monitoring, you have a chance to stop doing whatever is being doing and take a different approach. So monitoring is a very, very crucial part of mitigation in any environmental impact assessment process. I think when environmental impact assessment started, there were considerable uncertainties, and monitoring has made that so much better. Predictions of impact now compared to 30 years ago are very much more accurate, and we have monitoring to thank for that. But as I said, adaptive management is a relatively recent strategy. Because again, there was less monitoring in the past, or it wasn't feasible to do as much real-time monitoring as is done now. You know, many sensors and the advances we have in being able to communicate have made real-time monitoring so much more simple. And that ability to real-time monitor has been crucial in adaptive management. I also worked on a dredging project in Australia, and you know, there were people who were pretty much dedicated to watching the monitoring to safeguard the environment. But at Darwin, the adaptive management had to be far more sensitive. It was less crucial for London Gateway to be looking and having, you know, somebody real-time. There was real-time monitoring, but it wasn't necessarily monitored full-time in the way that the Australian dredging projects, which are in this much more sensitive, stable, pristine environment, you would want to make sure that, you know, the response was as quick as possible. It's much more adaptable if you're only perturbing the environment within its natural rhythms. The chances are you're not going to have to intervene unless something, you know, very unforeseen happens. For example, because the Thames is an extremely busy river, things do happen, like collision of vessels, for example, and you might have an emergency spill response. That's not the same thing as having the ordinary action of the project. So despite the environmental impacts being undertaken in different regulatory regimes, the similar methods of having mitigation of monitoring and adaptive management resulted in similar requirements. So the difference was the magnitude of the effects. It is a minor impact predicted in Thames, and indeed it was minor impact, but without mitigation, a major impact could have taken place in Darwin, but it didn't, because mitigation was thoroughly considered, and the adaptive management safeguarded a very, very nice environment. So I'd like to bring this to some conclusions. And that is that in environmental impact assessment, it is crucial to look at all of the environment. Very similar projects can have very, very different effects and thus different impacts, depending on the sensitivity of the receptors. And that's not just biological receptors, that's also human receptors. You know, if you just go back to Darwin and the Thames for a moment, you know, the effect on the human environment in the Thames could be very much higher, because there is so much more economic activity, there's more leisure activity, just because there are so many more people in the area than in Darwin. There was a lot more local fishing, there was a lot more, in fact, there in the Thames Gateway, there are also some very large shellfish beds, and obviously deposition of sediment onto shellfish beds would also be an issue, which is one of the reasons that the monitoring also had to be relatively good in the Thames, and that there was real-time data available. It wasn't necessarily monitored real time by a person. You know, there was no person looking at the real-time data all the time. But when there were questions about whether the shellfish had suffered, it was useful to go back and look at, well, what happened at this time? Were there weather events? Were there temperature fluctuations? Or was there a very high output of sediment from the dredging project that may have had an effect on these filter feeding shellfish? And that was looked at in quite considerable detail, because that was something that was challenged during and after the project. The people who relied on the shellfish beds were, you know, concerned that the shellfish beds had been affected by the project, and that monitoring was available for people to look at and actually draw robust conclusions that actually no, the variation in the shellfish stocks was within the normal parameters of normal variation of shellfish stocks. Unfortunately, they again are very much affected by what's going on in the macro environment. What's the temperature? What's the salinity? What's the suspended sediments naturally? So this presentation has focused on a very brief comparison of suspended sediment concentrations for similar scale methodologies. The dredging within the Thames, the effect is relatively minor. Within Darwin Harbour, the effect is relatively major. But this is one small aspect, the suspended sediments of a dredging project. There are so many more things that go into an environmental impact assessment, so many different aspects that need consideration, and need consideration either on their own or in combination with others. It's this is something that Darwin did not have to contend with. Within Darwin Harbour, their dredging project was the only dredging project. Within the Thames, there are dredging projects up and down it all the time. This was more or less an outer estuary area that was being dredged, but right up into the heart of London, there are small wharves, there are bigger ports that are all doing their own dredging projects. So they're all contributing to suspended sediments going into the water. So trying to isolate out just one project's impacts was much more challenging in the case of London Gateway. That, you know, this is something that you have to think about. Is this going to happen? Is the project going to happen in isolation? Or are there other projects going on in a similar area which might have overlapping effects? And might those effects overlap in such a way as to be worse than just additive? It's always possible. But in the case of the ecology in the Thames and within Darwin Harbour, the ecology is adapted to the respective environment. So the Thames is this muddy, highly turbid estuary. The ecology is used to the mud banks moving, the sediment, being picked up and deposited just by tidal action. Even if you had a very still day with no waves, sediment is going to be raised and lowered just by the action of tides going in and out. However, within Darwin, you have clear water a great deal of the time. They do have very occasional typhoons. And as a result of that, there are occasional, but the ecology does not have to continuously adapt to it in the way that the Thames ecology does. So you have these pretty stationary elements such as corals that are there, that are reliant on their photosynthetic partners. And, they need to have this much clearer thing. And you could apply this to various different aspects of environmental impact assessment. One should never think, oh, there was a very similar project to mine. It was a similar scale. I'll go to their environmental impact assessment and we'll just have a think. Those are probably all the same for our project. They are absolutely not. Every single environmental impact assessment will have different conditions. The environment will be different, and everything needs very careful consideration on its own merits. Thank you so much for listening. And I would like to invite questions now.
Thank you, Mary. And insightful presentation of contrasting two places to understand how to do environmental impact assessment. I think this is a methodology that should be really at the basis of the future of environmental assessment. But here we are, we have many questions. I have myself a question, but I want first the audience to ask you a question. Here we have Kadir Oran. He asked you, would the type of dredger used or the dredging speed affect the turbidity caused?
Absolutely. So a backhoe dredger is similar to the types of mechanical diggers that you see digging up the road. They have a long arm and they go down and they scoop, and a lot of sediment is lost from a backhoe dredger. You can change the bucket on a backhoe dredger to have a flap that closes as you bring the bucket up. That reduces the amount of sediment. Cutter suction dredgers may be needed in areas of things like rock, because as it sounds, they have a cutting blade that goes through rock. And they have a suction mechanism to pull the sediment up. But as you pull sediment up in any type of suction, you also bring up a great deal of water. And both cutter suction dredgers and trailing suction hopper dredgers will pull the sediment up into the ship, and they have an open top and they overflow at the sides to allow the water back out. The amount of overflow over the sides of the dredgers can be adjusted so that less sediment is lost in that overflow process. But you can see in both cases, you'd never pull it up in one go, overflow over the edges without losing sediment. But yes, you can absolutely adjust speed, you can adjust area sometimes. You know, it might be a case of, well, we need to stop dredging in this particular area, but we can now move our equipment to a different part of the channel and dredge there for a while whilst our initial area recovers. So I hope that helps.
Thank you. I'm now going to several questions, trying to synthesize or maybe take one piece of one question and add the next one, because they're all related. And first of all, they thank you for the interesting and informative presentation. The first is how accepted is the dredge material disposal at sea worldwide? And what are the techniques that could reduce sediment plume dispersion at the dumping site? I start with this one. Thank you.
Okay, so yeah, I hadn't even got into sediment disposal because I was concentrating on just the one aspect. Sediment disposal at sea, well, let's just take dredge sediment disposal as a whole. There are various ways to deal with dredge sediments. Disposal should be the last option. There are often ways that you can absolutely use those things usefully. So in the case of, I will take those two because they're both quite nice illustrations of using it constructively. In the case of Darwin Harbour, they wanted to actually build an artificial quay, and the dredged material was put behind a built bund to actually act as land reclamation to build up a new straight quay. I think if you noticed, you will see that the if you looked at it from above, it was a nice rocky area which wasn't particularly straightforward in terms of having a quay. So they took much of the dredged material and put it as infill to actually be land reclamation for this requirement for straight quays in the LNG. I think they even used some of it to level out some of the terrain as well. In the case of London Gateway, the material was clean and acceptable enough. One of the things that you do have to consider when dredging is what is the sediment quality, not just the water quality. I discussed the water quality, but the sediment quality itself. What can you do with it? Because places like the Thames, there are definitely, not in the estuary, in the outer estuary where most of Thames Gateway were, but further up into the centre of the city of London, some of the sediments definitely have associated contaminants. Again, from 2,000 years of people working, living, etc., beside the Thames. But the sediment quality from most of Gateway's dredging was extremely good. And it was actually used for some salt marsh reclamation. So I mentioned that salt marsh plants actually thrive on having extra sediments. You know, they need the sediment too. And on the East Coast, there is a lovely, lovely project which is now run by the Royal Society for Protection of Birds. The whole thing is a nature reserve, and it was returning previously drained agricultural land back to salt marsh. Now, there are various reasons to do this, but the dredge material from the Thames Gateway was used to reshape big creeks and rivers and the drainage that is required to encourage salt marsh to naturally regenerate. So it was used to enhance natural biodiversity. So it actually played into a mitigation for any salt marsh that might have been adversely affected by the dredging within the estuary. Acceptability worldwide. Again, a lot of it hinges, I think, on sediment quality. If you can't use it in a beneficial way, and many places will look to use sediment as beneficially as they possibly can, I think then it's very much down to individual regulators. But I think many, many maritime nations have areas where it is acceptable to relocate dredged material, so long as that dredged material, you know, has no problem with the environment. When you do, interestingly, what happens in the Thames, in the areas I was talking about, which do have contaminants associated with them, many of them do not dredge in terms of bringing the sediments to the surface. Instead, what they tend to do is use something either known as agitation dredging or water injection dredging, where they fairly gently lift the sediment from the bed and move it downstream slightly, so that it just clears the berth area, but it stays within the overall area. That means the contamination doesn't get a chance to move around too much. It stays within the system, which is already contaminated. If they had to remove it from the seabed, it would not be acceptable to go to sea disposal. It would have to be disposed of at a hazardous waste facility on land, which is prohibitively expensive. I mean, and that's something that I may not have discussed particularly in the presentation, and that is and possibly lectures either, and that is that you often have to be very pragmatic in environmental impact assessment. You have to realize that the methods of mitigation, the methods of looking after the environment have to be proportionate. If you come up with the best thing in the world, but it is prohibitively expensive, it's never going to happen. So there is always consider of proportionality as well. I think I covered all of that.
Well, thank you. We have still, if we still can get a bit more of your time, we still have another interesting question here by David that talks about Darwin. Darwin
Okay.
has been dredged previously at similar scales, but it's still pristine. How is natural system robustness taken into account in the adaptive management?
I think that was what I was trying to get at, that, if you monitor each time you do things, you get a better feel for such things, that you have to, you start off with the precautionary principle. So we don't know if this is going to get really bad or not. So we'll assume it'll get really bad and do the, and set our thresholds at low areas. So if the natural is 72, let's try 150% of that and see if everything is okay. And then we can gradually increase those thresholds until we see an effect. And I think, there's no hard and fast way of saying we can definitely set this. That's not how it works. This is a natural environment. It has natural variation. There are, if we go back to just the Australian environment and corals, there are corals in Darwin. They have been subject to terrible bleaching events due to high temperatures. And some corals recover and some corals don't. And you can't tell before the bleaching event what's going to recover and what isn't, and what level of recovery is acceptable, what length of time of recovery is acceptable. And there is a lot of debate on those things. And this is often where getting in touch with the regulators, if you're sitting on the side of doing the environmental impact assessment, the people in charge of regulating such things will have their own opinions on such things. And often there is debate between, the project proponent, the people who, want to do it as quickly and as cheaply as possible. They'll always want to do it as quickly and cheaply as possible. But most are responsible and, do also recognize that they need to protect the environment for all the right reasons. But you'll have a tension between, how can we do this the best way? How can we do this the cheapest way? But getting in contact with the regulators, having that evidence of monitoring if you can, applying the precautionary principle. These are all ways of thrashing out how you come to the thresholds that keep things as pristine as possible. And I would say that, that's probably played out really well in Darwin, that, it's still a lovely environment because people started with a precautionary principle. We'll start, very carefully, and we'll gradually push and see where those boundaries are with monitoring.
Yes, so thank you. We have another question here that is, well, we have several, but I have to make a selection. Kadir talks about aquaculture, that is rather sort of, with respect to other activities in a port, new activity, only 30 years, let's say, 20, 30 years. In aquaculture, the physical criteria such as current speeds and wave heights are considered to set the threshold for dissolved or solid wastes the system can handle. And are such ideal conditions established for dredging?
Well, as I said, I mean, you can think of this in different ways. The shellfish beds in the Thames were aquaculture of a type. I mean, you might be talking about different types of aquaculture in terms of perhaps fish farms within the marine environment. But again, this is all a negotiation of understanding what is required in one environment, how it might affect in terms of how the dredging takes place. It might be that, for example, the aquaculture area is upstream of certain parts of the dredging and it is unaffected. If it is downstream, it might be that the dredging needs to take place on an incoming tide so that sediments are moved away from the aquaculture area. And, you know, these sort of mitigation measures, it's working out that pathway of effect, which I definitely did talk about in the lectures, that where your dredger is, the pathway of where the suspended sediment concentrations are expected to go, how much is that going to overlap with your aquaculture area? At what stages of the tide, under what conditions? So once you have established what sort of thing is going to emanate from the dredger, how big is your plume going to be? What sort of levels are your plume going to have? So your plume might have high suspended sediment concentrations close to the dredger and very rapidly either fall out of the water column or definitely dilute quite highly. It might be that if they don't come within 200 meters of your aquaculture, there is a negligible effect, but there might be a minor effect, there might be a major effect. The impact, how reversible is it? Is the outgoing tide going to drag lots of new sediment through your aquaculture area if you're only dredging on the incoming tide? Possibly, possibly not. There are so many different variables. You can't be prescriptive. I mean, that's really what the message of my presentation is. You can never be prescriptive about any one area. You can make educated guesses, and then you need to have a look at it a bit harder. But you need to work out where are those receptors in the case of aquaculture, you know, the conditions that you put on your aquaculture, how are those going to be, what is the pathway of effect between the dredging project and your aquaculture? And how is that pathway of effect, what level of influence does that pathway of effect actually have? And how could you mitigate that pathway of impact? For example, by looking at the tides and trying to make sure that, or, you know, using the methods we were discussing about lessening the amount of sediment or whatever emanating by changing the methodology of dredging. If that's possible, as I said, something like a cutter suction dredger, you don't really get too much of an option if you actually have hard enough sediment that needs to come out that it needs cutting. But yes, can't be prescriptive, I'm afraid.
Fantastic, Mary. Thank you. I have actually a last question from myself.
Okay.
Thinking about your complex answers and the presentation that is giving us an overall framework, I wonder if environmental impact assessment if you can, just say something about environmental impact assessment being part of marine spatial planning.
Marine spatial planning, yes. I think it is. I think, in terms of marine spatial planning, again, something I have been involved with in the past, purely from the UK's point of view. It's always useful to have a thought about, marine spatial planning is almost always about trying to share the marine environment in an equitable way. So you might have an area that the Thames is actually very good sort of case study for marine spatial planning, I would say, because so much is happening all in the same space. There are wind farms in there. There are wonderful nature reserves. People always tend to be a little bit surprised, but there are huge amounts of wintering birds that crop up in the overall Thames estuary because it's got a few deltas and things. There are rare fish in the area. There is one species of subspecies of herring which exists nowhere other than the Thames estuary, for example. Herring are very sensitive to sound, so they have their challenges. There are wind farms. There are various people enjoying recreational pursuits around the beaches, and there's a big sailing, recreational sailing. When you hit marine spatial planning, I think it's virtually impossible to create what we are discussing, an equitable access to the marine resources, without considering environmental impact assessment of all these different things and how they interact with each other. It turns out that, putting a wind farm in the outer estuary, piling might affect those herring who are sensitive to noise. So you have to mitigate for that. But when they're actually in and fishing is restricted between the piles, you end up with a nursery area for them. So it's a complicated, I think there is complexity in marine spatial planning that's almost impossible to accomplish if you don't have these considerations of the environmental impacts of both new projects and ongoing activities in an area, and how those synergize or contradict with each other. Does that make sense, Nadia?
Yes, very much so. Thank you. And we should really put this into practice. Thank you so
Definitely.
much. Thank you very much. And now we have a last announcement. Yeah. And thank you again. Thank all also the questioners. They are real nice questions, and more maybe in a future seminar by Mary. Thank you. So next webinar. Yes, are we showing the next one?
Yes, it's this one.
Are we?
Yes.
Okay. Yeah. So do you want to say it?
Yeah, you can say it.
Yes, of course. We will meet again on March the 18th. We will meet with Michael Nappen. There is actually a colleague of yours, Mary.
Yes.
He's from HR Wallingford, as you are. And then we'll have Jacopo Alessandri. There is a fellow PhD student from University of Bologna.
No,
Research.
he's already a
Research.
researcher, but he's young. University of Bologna, yes.
So we'll meet again, and it will be an open event. as well. So you will hear from us.
Thank you.
Bye.